Welcome to this eLearn Security video lesson on acquiring network traffic using Tcpdump. In this video, we will be using a tool called Tcpdump. Tcpdump is the traffic acquisition tool of choice when it comes to performance. Due to its low overhead and the lack of graphical user interface, the traffic capturing and analysis process requires less memory. As you can imagine, this is of great importance when capturing and analyzing the traffic of a big network. Tcpdump is the best tool for this, and you will most likely need it for traffic acquisition. In other words, traffic capturing. To use Tcpdump, we need to use it with root privileges. So, I'm going to use it with sudo, like this. Or we can use the -n switch. We can now see that it is capturing the traffic. Let's open this web explorer to see what type of traffic is being captured and what the N switch means. Some traffic has been generated when we open this. I also pressed Ctrl+C to stop it. The first column represents the arrival date of the packet. To the right of that, this represents the protocol carrying the packet. This represents the source IP of the packet. Here's the source port of the packet. That is, which port this is coming from. This represents the flow direction. So, this IP is communicating with this IP, which is the destination. And this is the destination port. Here we see the flags. For example, here we have P, which is for push. Here we have S for SYN packet. Here's the sequence number, the window frame size, and other options. I like to use the N switch because it displays the results in a numeric format. It won't display results using any host resolution. So let's remove this and do another test. I'll also press Ctrl+C again. Here we can see the home router, CPE domain. We can also see that there's been some resolution. Let's do another test. I'll go ahead and run it again. Now, let's go to eLearn Security. So now we can see a lot of resolutions. If we can resolve an IP to a hostname, it will do that. It won't display details in numeric values, except when there's no resolution for an IP address. So, what if we wanted to specify the type of interface? If we type in ifconfig, it displays the interfaces we have on our machine. We can specify the type of interface we want to use with the -I switch, and then specify the interface we want. We only have one interface, which is why I specified ETH0. This is extremely useful when you want to listen to a specific interface. And here, we can see that we are now listening to this specific interface. What if we want to run a specific interface but only capture 5 packets? -C will allow us to do that, and we'll be able to capture only 5 packets. So here we have the first and second packet. Now we have the third and fourth packet as well as the fifth. Here we can see that 5 packets have been captured and 0 packets have been dropped by the kernel. This is very useful when you want to capture a specific number of packets. So now, let's say that you want to capture 2 packets, but we want it displayed in ASCII format. We can do that by using -A. We saw these details earlier and know what this means. This here is the duration, and this is the arrival time. Here's the protocol that is carrying the packet. This is the source IP and source port. This is the destination IP and destination port. This is the protocol, and lastly, we have the length of the packet. Here we can see the contents of this packet, and it's displayed in ASCII, as that is what we specified. What if we no longer want to display it in ASCII, and we want to display it in hexadecimal? We can do that with the -XX switch. Now, everything is displayed in hexadecimal. What if we want to check the source and destination of the MAC addresses? We can do that using the -E switch. It will try to add the MAC addresses. This may be useful for you if you want to know what MAC addresses are available. As you can see here, it will use the MAC address of the source and the MAC address of the destination, which usually might be the router, instead of IP addresses. What if we want to show the inter-arrival time instead of the arrival time in the results? We can do that with -TTT. This will show the inter-arrival time instead of the arrival time of the results. Everything we've seen thus far was simply displaying results on the fly. So, we haven't actually captured anything. But what if we want to capture something? What if we want to store what we are capturing? For example, we can do this by using -C. And let's say we want to capture 10 packets, and then write .pcap to capture it. Now, it will capture 10 packets, and it's also listening on Ethernet 0. Let's go to our web browser real quick. So now, it shows us that 10 packets were captured and stored in the file, and we used the -W switch to capture them. What if we want to read this file? We can use -R and then capture .pcap to read the capture. So, -W will write to a capture file, while -R will read the capture. You can also apply the filters, which we did early with -A and -XX. So, -A will read the capture file and interpret all the details in ASCII values. What -XX will do is read the capture and interpret the results using hexadecimal. And here we can see the details. What if we want to capture packets that are greater than a specific size? We can do that by entering greater and then a specific size. I'll use 1024. Here we see that these packets are all greater than 1024. So all you need to do is specify the packet size in bytes, and here we can see they are greater than our specified size. What if we want to use packets that are less than this size? We can simply change greater to less. Let's go ahead and write this too. We'll say write less.pcap. So this will write any packets that are less than 1024. Now I'm going to do some browsing to generate some packets. Here we can see that 484 packets were captured. Now let's read the pcap by typing in sudo tcpdump -r less.pcap. All of the packets are displayed. We can see various lengths, ranging from 46 to 319 to 93, and many more. This is really useful when you want to filter traffic based on capture size. What if we want to capture traffic, but for a specific protocol? So let's type in tcpdump and then -n for a specific numeric. And then we want to capture the ARP protocol. Let's also add a few more things, -C2, so we capture 2 packets. So now, we're going to only filter out any traffic that is ARP, and we want to capture 2 packets. So we need to wait for just a bit. Let's try a different protocol. Let's use TCP. We can see here that as soon as we specified the protocol, we got the results back. So, both of these packets are actually using the TCP protocol, which is why they were captured. This is based on protocol, but instead of specifying the protocol, what if we wanted to specify the port? Let's say we want port 443, and we also want to capture 4 packets going to this port, which is for the HTTPS. Here we have 2 packets. And here's our final 2. So, we were able to capture 4 packets and specify the destination port. What if we want to capture traffic for a specific source IP? So, let's type in sudo tcpdump -n -c, and then we want to capture 4 packets. Now, let's enter src and that we want to capture for this IP address here. So this will capture traffic in numerical format, capture 4 packets, and the source is 10.0.2.15. So, here we can see that all 4 of these packets have a source IP like that. Let's add another filtering layer and put in port 80. Also, let's change the source to destination. We'll use this here. We'll update source to DST, and then let's add this. And let's actually change the port from 80 to 443. I forgot to add the AND. I'll do that now. Now, this will capture traffic going to this IP that's going to this specific port. It will only capture 4 packets. Let's go over to our web browser really quick. So, we managed to capture 4 packets going to the destination 64, 233, 167, 156 on port 443. Can we store this? Yes, we can. We can just enter -w dst 1.pcap. Let's just generate some traffic. Finally, we got some traffic. If we want to read it, we'll just enter in what we've done previously, tcpdump -r and dst 1.pcap. This is the traffic we captured. This is very useful when you want to specify and capture traffic as well as apply filters. This time, let's capture 2 DST2 and we'll do another filter. Let's capture 10 packets, and this time we'll specify not TCP and ICMP. Let's go here and do a ping to elearnsecurity.com. Great, we finished. Let's just stop this one here. Let's clear this. So in this capture, we specified that we didn't want any TCP by inputting not TCP. And then we also specified that we wanted only ICMPs by inputting and ICMP. So now, if we enter tcpdump -r and then dst 2.pcap, what we'll only see is ICMP packets. There are a lot of capture filters that can be applied. I highly recommend you check this out. All you need to know is the BPF, the Berkeley Packet Filtering Directives, that are being used so you can easily switch between these filters and even apply your own filters. There are more complex filters, but these are the basics to get you started. I want to add one final point before we conclude this video lesson. Let's enter in sudo tcpdump -c, and we'll capture 4 packets. Next, we'll type in not ARP and not ICMP, but we want to go to the destination www.google.com. I just needed to add the "and" at the end. So, let's run this in the background, and now let's go to google.com. We managed to capture 4 packets, which are not ARP and are also not ICMP, but we wanted to capture packets when the destination was the hostname. I wanted to show you this, as in the hostname you don't have to specify IP addresses, rather, we can just specify a hostname. This one here did not work because the hostname was misspelled, and I did not put the AND directive after not ICMP. To continue, it needed to know what I wanted it to do. When we went to DST, it captured all of these packets that were destined to google.com. So, that's all for this video. I hope you found this video beneficial to you, and that you start capturing traffic using Tcpdump. All you need is to practice a few times, and then you should be good to go to capture your own network traffic. And this concludes our video lesson on acquiring network traffic using Tcpdump.